because 14 billion years later, the expansion of the universe has redshifted the ultraviolet into the infrared. So if you want to see the birth of galaxies, you got to know what they look like in the here and the now. And in the here and the now, it's in the infrared. So this is a telescope specifically tuned to see galaxies born at the edge of the universe. And infrared also allows you to see deep into gas clouds.
Now, when they're showing you an image like
So right here, this is the pillars of creation, which were so named at the time Hubble first attempted this. We were gaga over the Hubble image of this. And now, like the JWST, oh my gosh. For those who are more prone to religion, some have called this the hand of God. Because if you look at the pillars, you can kind of picture like a thumb and fingers, yeah. So, but regardless, this is nearby. This is the telescope peering deep into gas clouds that otherwise would enshroud what's going on. And you get to see stars being born, planets being born. And so what's remarkable about JWST is that to be tuned for the edge of the universe and the birth of galaxies is the same properties you would want to see the birth of stars. A star is born right in front of your nose that would otherwise be cloaked by gas. And infrared penetrates those clouds and enables you to see it as though the cloud isn't even there. And you already know this because if you're driving through fog, okay, you put on your fog lights. The fog lights are not blue. They're like reddish, amber, okay? That improves your ability to see through the fog. If we could see infrared, that's the kind of light you'd use, then you wouldn't even know the fog was there. That's why self-driving cars will be amazing. It won't matter if it's foggy. They'll be able to see everything. Just give them infrared sensors. The fog is irrelevant. They can drive 100 miles an hour in dense fog, and all the cars will see each other. And they want to change lanes. They tell other cars, I'm going to change lanes. They'll part for them, open up, and we won't get 40,000 deaths a year, as we currently do, from automobile accidents.
Now, how much bigger is this telescope?
So, so you want to think about collecting area, and I forgot the exact number, something like 8 times around there, more powerful in the sense of it can see things 8 times dimmer. There you go. So that's wow. It's about 2.5 squared. It's about 8 times the area.
And the technology obviously is improved as well. So like the ability that...
Well, our detectors are better. And let me remind you that when the Hubble was designed, it was designed in like the 1980s. And it was scheduled to go up. And then we had the Challenger accident. And that delayed the shuttle program. So there's Hubble sitting there in mothballs with an old Microsoft chip. And by the time it launched, it was already not as fast as it could have been. And so the very first servicing mission swapped all that out and put in better methods and tools for measuring what it is we always needed it to do. So one sad part about this is that it's not serviceable. We have no access to that point in space 1 million miles from the moon. We haven't left low Earth orbit since 1972. We're not going out 1 million miles from Earth to fix a telescope. So that's unfortunate. Maybe a robotic fix, I don't know, to refill some of the fuel. It needs fuel to station keep.
Didn't it get hit by a micrometeor?
Yeah, well, that's the brakes when you're in space.
Yeah.
Yeah, but it doesn't affect the overall performance.
That's amazing.
Yeah. Well, it's huge, and micrometeors will do small damage, but you don't want it in the middle of a meteor storm. That would be totally bad.
And do they? I mean, they obviously know like where some of the asteroid belts are and where some of the nearby Earth objects are.
Yeah. So in this context, so first, most asteroids are in the asteroid belt. So that's between Mars and Jupiter. So I have an asteroid named after me. And
Congratulations.
I don't mean to brag or anything.
Can't you like get a star named after you online?
Not authentically.
You just get robbed. They just pretend
to send you a map with your name drawn in the map.
So you pay for a piece of paper.
Yeah, they claim that it gets registered with the astrophysicist, but it doesn't. No, there's only one way we name stars, and that's by committee and by traditions and this sort of thing. They're fascinating traditions. So planets are named after Roman gods, and planet moons are named after Greek characters in the life of the Greek god, who's the counterpart to that Roman god.
Wow.
So Jupiter, for example, one of its moons is Ganymede. Ganymede was the manservant of Zeus, and Zeus and Jupiter were corresponding gods in Greek and Roman. And not only that, what's the number? Is it about half, somewhere around there, of all the stars in the night sky that have names have Arabic names. So in my field, we have deep respect for people who made great inroads into understanding the natural universe. And the golden age of Islam from 1,000 years ago made material contributions in this regard. And of course, Greek and Roman legends and this sort of thing. So there they are in its influence on Western culture. So yeah, no, the universe is a fun place.
Pretty fun place.
Oh, yeah.
So this James Webb Telescope, in terms of its ability to recognize things, like what magnitude of improvement are we talking about from the
factor of
Hubble?
10. Yeah, about a factor of 10. Yeah, easily. That's right. Well, a factor of 10 for the things Hubble could see, but it's incalculable when it sees things that Hubble could have never seen because Hubble was not tuned for the infrared. So then you can't even compare it. It's a complete other window opened up to the universe for you.
So what has changed in terms of our understanding? The Webb has been in the million-mile orbit, or however far away it is, for how long now?
Well, it got there, and then we did some engineering. So I guess a year and a half. Yeah.
And what has changed in our understanding?
So that's been people's first question. And what I want to do is temper that to say something a little different. So, yes, we expect James Webb to make great discoveries. We expect that. But the first order of business is hardly ever, let's discover something new today. It's, here's something that we have limited understanding of. Let's improve on that. And in so doing, we deepen our understanding of how things work in the universe. That doesn't always involve overturning a previous idea or discovering something that nobody ordered. All right? That will happen. We fully expect that to happen. But we targeted parts of the sky initially because we know other telescopes have gone there before. And we're going to say, how can we further advance and deepen our understanding? One thing it's going to be able to do, and it has already done, we have, you know how many exoplanets there are?